Okay, so get ready to put your math skills to work to solve this interesting little math word problem. Matter of fact, let me go ahead and read the problem. It is as follows. Ed has 120 feet of fencing. He wants to put a fence around a rectangular plot next to a river. Find the maximum area he can enclose with this amount of fencing. All right, so this is the question. Feel free to use a calculator, but if you can figure this out, we'll go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'll solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, let's take one more look at the question before we show you the answer. So Ed has 120 feet of fencing. All right, now we're talking about obviously some sort of fence, like a chain link fence probably is the most likely scenario. And he wants to put a fence around a rectangular plot of land next to a river. Now this part of the problem could be a little bit confusing. So we have a river and the fence is going to make up three sections of this rectangular plot. Okay, not all four sides because the back of this side right here of what we're enclosing is the actual river, right? So that's an important detail just in case you were confused about what the problem is saying. We're only talking about three sections here, but we have some sort of width and some sort of length that we need to kind of make this U section of the fence with this 120 feet, or Ed does. But the kind of the objective here is to maximize the area that he can enclose. Okay, so that obviously is the question. Find the maximum area that he can enclose with this amount of fencing. All right, so hopefully you understand the question and hopefully you got the right answer, which is 1,800 square feet. All right, now if you got this right, that is super impressive. Matter of fact, I have to give you a nice little happy face, an A plus, a 100%, and multiple stars. So you can tell your friends and family that indeed you are a certified professional expert in finding the maximum area or really kind of figuring out an optimization problem, okay? Because this is what we're talking about here. Uh, Anytime you see the words maximum or minimum in a math problem, okay, we're talking about something called optimization, which is a big deal in calculus. But in this particular problem, you need to know a thing or two about quadratic functions, specifically parabolas. So again, if you got this right, that is super impressive. But if you didn't get this right, no worries. Let's get into the solution right now. By the time this video finishes, you'll be a certified professional expert as well. All right, so first things first, we have a lovely math word problem. Always use the rule of three. Read this thing at least 3 times before you do anything. Now, I've already read it a couple times, but if you're confused about a problem, and let's say you are a math student taking a test or whatnot, raise your hand and say, hey, teacher, what's going on? I don't really kind of understand that. Hopefully, they'll give you some details. But if you don't understand a problem, you're not going to be able to solve it, right? So this particular part about this fence, rectangular fence next to a river could be confusing. But the best way to kind of really make sure you're clear on the information in the problem is to try to model it, okay? And in this case, we can certainly come up with a nice, lovely sketch that represents what's going on, all right? So let's go ahead and take a look at my little picture. And here we have this river, okay? Now we have 120 feet of fencing, and of course we have this rectangular plot that we want to enclose. Now again, the river is going to be the back of this enclosure, right? So, we don't need, this kind of other fence part right there. So we have three sections to make up from this 120 feet of fencing. Now, the maximum area is going to be the width times the length, right? Because the area of a rectangle is length times width. So we need to figure out the maximum area. Now, you might be saying to yourself, well, 120 feet, maybe you can just put two equal sides here, a little bit here. Maybe it's not going to make a difference. Well, it actually makes a big difference in terms of what width and length do you use here? Okay, matter of fact, let's go ahead and take a look at some examples. All right, so if I have 120 feet of fencing, and let's suppose we want to kind of configure our fence in this manner. Okay, again, this back part of this rectangular plot is the river, so we're only talking about 3 sections. But we could split up this 120 feet this way. We could have 10 feet and 10 feet. Remember, we are dealing with a rectangle, so these sides, the widths are the same. So we can have 10 and 10, and so that's, of course, 20. That leaves us with 100 right here for a grand total of 120 in terms of our how much fence we have. So the area is 100 times 10, okay, which is 1,000 square feet. That seems pretty good, but can we do better? Well, maybe let's increase the width and then maybe we'll kind of decrease the length. So let's say we have 20 by 80. Well, 20 by 80, if we get the area there, we're going to have 1,600 square feet. So definitely better. So again, there is a specific configuration where we have the maximum amount of area. So what are these numbers? What is the best width and length to max out the area here? Well, this type of problem, again, is called an optimization problem. All right, but we're going to be using algebra, and what we're going to do is we're going to let this variable x represent the width of our rectangular plot. Okay, so if we have x over here, because this is a rectangle, we have x right here, and the length is this expression right here, 120 minus 2x. Now, why is that? Okay, a lot of you might be saying, come on, Mr. YouTube Math Man, I'm a little lost. Where's that 120 minus 2x coming from? Well, let's go ahead and figure that out right now because this is very important. Okay, so let's suppose we don't know how to express this length, right? Where this is the width, this is the length of this rectangle, but we do know that this x, the width, and this x plus the length, right? The width and this length has to add up to 120. So we have x plus the length, okay, which is this right here, is equal to 120. So we could kind of just solve for the quote-unquote length, okay? And whatever expression is left is this 120 minus 2x. Let me show you what I'm talking about right now. Okay, so x plus x is 2x, so 2x plus the length is 120. So I can solve for the length, if you will, by subtracting, okay, 2x from both sides of the equation. Okay, so if I subtract 2x from both sides of the equation, I'm left with the length is equal to 120 minus 2x. Okay, so you see that right there? So the length of this rectangle is this expression right here, 120 minus 2x. So that's how we come up with our 120 minus 2x. All right, so again, what we want to do here is find the area now of this enclosure, and the area is equal to the length times the width. So in this case, it would be x times 120 minus 2x. All right, so we need to kind of maximize this. So let's go ahead and take a look at what we have here. So the area of this enclosure, and we can have this algebraic variable model, x times 120 minus 2x, represent the area, okay, of this particular enclosure. What we want to do here is find the, we want to maximize this, okay? Again, maximization or minimization is part of a broader topic called optimization, which is all over the place in math. And this is where this problem is going to start getting very interesting. All right, so area is equal to x times 120 minus x. Let's go ahead and distribute this x in. So we have x times 120, that's 120x. X times minus 2x, so that's minus 2x squared. All right, so let's go ahead and clean this up. Anytime you have an x squared or an x or any kind of polynomial, always write it in standard form, highest to lowest power. So that's going to give us area is equal to minus 2x squared plus 120x. All right, so here is kind of like the big picture that we want to focus in on. So what does x represent? All right, so let's not lose sight of what x is. X is the width of this rectangle. Now, once we figure out what x is, we can easily figure out the length, okay? But x and 120 minus 2x, if we solve for x, we'll get the actual dimensions of this rectangular plot, and then, of course, we can calculate out the maximum area, okay? So that's what x is, and a is the area, right? We just multiplied the length times the width. But what I'm going to do is I'm going to uh, use a different variable for a. I'm going to use y, okay? So we have y is equal to minus 2x squared plus 120x, because what we have right here is a quadratic equation, okay? And we can graph this quadratic equation, and the graph of a quadratic equation, hopefully you know, is a parabola, okay? It's some sort of parabola. Now, what type of parabola is this? Well, there's two types of parabolas. A parabola is a U-shaped kind of graph. Again, it's the graph of a quadratic function. So we have happy parabolas, and then we have parabolas that are sad to be parabolas like this. So how do we know if we have an up parabola like this or a down parabola like that? Well, the way to know is to look at the sign of the leading coefficient. Okay, so in other words, we go to our x squared, and if it's negative, well, then we have a sad parabola. If this was a positive number, we would have a happy parabola. Okay, so hopefully you remember that. And I'm going over a lot of algebra here. If you're struggling with quadratic equations, parabolas, all this type of stuff, I will give you some specific recommendations here in just 1 second. But what we have, again, if we were to graph this, is some sort of sad parabola. And this makes sense because we are looking for the maximum, okay? You can't have the maximum like this. If you have a happy parabola, you would be looking for the minimum, okay? A upside down parabola like this, this is where it maxes out. All right, so again, what is x? Well, x represents the feet, okay, the amount of feet for the width of this fence. That's what the x variable represents, so that's the feet. And then y represents the area, okay, of this respective enclosure. All right, so what we want to do is figure out how many feet, okay, for our width should we have. There is a particular value, okay, that we want to figure out, and that amount is going to correspond to the maximum area. So really what we're talking about is finding the maximum or the very top of this parabola, and that is a specific xy point called the vertex. Okay, so this is what this question now is all about. How do we find the vertex of this function right here? Well, we're going to go ahead and get into a decent amount of algebra. And again, if you need help with this, don't despair. I will give you some very good recommendations, but let's go ahead and get into this right now. Okay, now before we look at exactly how to find the vertex of a parabola, let's have a quick look at this, which of course is an invitation for you to support this channel and to support this channel and what I'm trying to do, which of course is reach as many people as possible and help them in mathematics. Well, I can't do that unless I get help from people like yourself. Now, the way you can help me out is simply hitting that subscribe button. It really does a lot with that YouTube algorithm. And if you're going to do that, hit that notification bell as well so you can get my latest videos. Now, the stuff that we're doing in this particular video, parabolas, quadratic functions, all this kind of stuff, well, this is things that are taught like in Algebra 1, Algebra 2, certainly pre-calculus. And if you need help with any of this, well, I'm going to leave links to all my main full courses, which of course include Algebra 1, Algebra 2, and other courses. You'll find those in the description. But I also have a ton of additional videos on my YouTube channel that can help you out with this stuff as well. All right, so let's go ahead and finish this problem up. And the next thing that we need to do, again, is to figure out the vertex of this quadratic function. So we have y is equal to minus 2x squared plus 120x. Well, to find the vertex, right, which of course is the top of this parabola, all we need to do is use this formula right here. Okay, so the vertex is equal to minus b over 2a. This is our x coordinate for our vertex, and our y coordinate is f of minus b over 2a. Basically, we're going to get this x coordinate, and then that answer we're going to plug in to the function, and then we'll get the y coordinate. So let's go ahead and see how this is done. This is not that difficult. All right, so we have our a, b, and c values. Now the a, b, and c values that we're talking about are the same a, b, and c values that we use with the quadratic formula, if you're familiar with the quadratic formula. So the leading coefficient, in this case it's -2, this is our a value. The value in front of the x term is our b value, of course that's 120, so a is -2. Now we don't need c here for the vertex, but if we wanted to use the quadratic formula, you might be saying, hey, there's no c here. Well, we could just say plus 0, so c could be equal to 0. But all we need to figure out the vertex is our a and b values. All right, so this is pretty much just a substitution kind of scenario. We have b and a, so we're going to plug in a -2 right here, and for b, we'll plug in a 120, and let's go ahead and get our x component, or x coordinate for the vertex first, and then we'll go back and get the y coordinate. Again, don't let this formula scare you. This is not that difficult. All right, so minus b over 2a is going to be -120 over 2 times a, which of course, a again is -2 and b is 120. So we have -120 over 2 times -2 is -4. So -120 divided by -4, of course, is a positive 30. Okay, so we are almost done. That means for our vertex, okay, our x coordinate is 30. Now remember, our x-axis, our x variable, represents the feet, okay, in terms of the dimension here for our width on our lovely rectangular plot, okay? So we almost are done, but remember, the y component of our vertex represents the maximum area because that is the question. So we still have to figure out the y, which of course is the answer to this problem. And to do that, what we need to do is do this part of the formula, which is f of minus b over 2a. All that means is that we're going to take our x coordinate and plug it into the function. Okay, so when we do that, we will get our y. So minus b, or sorry, minus 2x squared, -2x squared, excuse me, plus 120x. So we are going to plug in a 30 right here, okay, because this 30 is the x coordinate for our vertex, right? So you got to get this first, and then we're going to plug in our value, which of course is 30, into our equation to get y. All right, so we have 30 squared, which of course is 900 times -2, and then 120 times 30. We'll do all this number crunching. This is not that difficult. So -2 times 900 is -1800, plus 120 times 30 is 3600, and when we add these together, we get 1800. All right, so that is our actual maximum area, okay, 1800 square feet. All right, now, again, you could go back and get the actual dimensions of this rectangular plot, but that is not the question. Now, I'm going to show you another way that we can use calculus to solve this problem. Let's go back up here and revisit our parabola. Okay, this is going to be a quick micro lesson on calculus. And how can we find the vertex, the very top of this point, using calculus? Well, there's something called the derivative, right? Now, the derivative is a formula that tells us the slope of anywhere along a curve, right? So slopes, if you know how to graph a line, lines that are going in this direction have a positive slope, lines that are going this way have a negative slope, and then lines that are completely horizontal have a slope that is 0. Okay, so if we look at this parabola here, anywhere as we're kind of, approaching this left-hand side of the parabola, the slope on the parabola is positive. Over here, it's downhill, so it's negative, right? But there is one point where the slope is 0, okay? And that point is right here at the maximum, okay? That's where the slope is 0, and then it kind of goes down here, downhill there, and then uphill right there. So if we can figure out along this parabola where the slope is 0, well, that indeed is our x value for the vertex. And this is so easy to figure out when you know a bit of calculus. All right, so I'm just going to show you this real quick. I'm not going to fully explain this because this video has already been a little bit long, but this is definitely worthy to see. All right, so here is our function, our quadratic function. Y is equal to -2x squared plus 120x. Okay, so what we're going to do here is get something called the first derivative, or y prime, in calculus. Now, this is not that difficult, okay? The first derivative is the formula for the slope, okay? This is the slope along our parabola, okay? Now, of course, I'm going very quickly here, in terms of explaining calculus. But the way we find the first derivative is I'm going to take this 2, I'm going to multiply by that negative 2. So 2 times negative 2 is negative 4. Then I'm going to drop this power down 1. So instead of x squared, I have x to the first. All right, this is how we find the derivative. You can see it's not that difficult when I'm doing. And then over here, I'm going to do the same thing. I have x to the first. I'm going to multiply by that number. So that's 120. And then I'm going to decrease the power by 1. So that's x to the 0 or just 1. Okay, so you just decrease the power by 1. This is a basic rule in terms of finding the first derivative of polynomials. Now, this is a huge topic because we are talking about calculus. But anyways, this is the first derivative. Okay, now what do we do with this? Well, this is the slope. And we want to say, hey, slope, when are you equal to 0? Because where you're equal to 0 is the maximum. So what we're going to do here is set this first derivative, negative 4x plus 120 equal to 0. And we're going to solve for x. Now let's just go ahead and do this real quick. So we're going to subtract 120 from both sides of the equation. I have negative 4x is equal to negative 120. And when I solve for x, I get x is equal to 30. It's the exact same answer. Now from there, I could take 30 and plug it back in to my original formula to get my 1800, which is the maximum area. But this is, again, a problem type called optimization. And you're definitely going to see it in all levels of math, in algebra, and it's a big part of calculus, okay? So that's why I really wanted to take my time and fully go through this, because if you are a serious math student, if you're really trying to learn this stuff, well, you're going to see optimization problems. Again, anytime you hear that word maximum, minimum, well, then again, you are dealing with a optimization scenario. All right, so hopefully this little video helped you out. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.